First of all, I will fill few elements in this array. So total I have 6 elements. So let the length of this array be 6. Now assume that already I have filled some elements in an array. Now based on this, let us look at these operations. So the first operation is to display. Let us see how we can display all the elements of an array. So first operation, display. Displaying or traversing an array is visiting all the elements of an array one by one. Now here I will show you the procedure by writing some pseudo code. Means not a complete function or a program. Afterwards we will see a complete program combining all these functions together. So let us see the logical part, how to perform the operation. So for that I will be writing the code. Now for displaying the element, suppose I want to display only the first element, then I should say printf %d a of 0. This will be printing just a first element, that is at index 0. But if I want to print all these elements, then here I should use index. So for that I can traverse through this array from index 0 to 5 by taking a for loop. So for I assign value 0. So initially I starts from 0. So here I can use I. Then I should go till where? Till 5. So that 5 is the number of elements. So 0 to 5 I have total 6 elements. So I should say I is less than length and then I plus plus. So here L is capital. Now this piece of code will print all the elements. First time I value will be 0, so it will print A of 0. The next I becomes plus plus, I becomes 1, so it will print A of 1, then A of 2, A of 3, so on up to A of 5. Now here, instead of using a specific C language syntax, I prefer saying print A of I. So this becomes a pseudocode. Now this doesn't belong to any particular language. It may be C language or C++ or any language. So in C language it becomes printf, and in C++ it may be cout. So this is the method for printing. Now let us go to the next operation, add. So I'll explain that operation, then I will show how it works. Now second operation is add or append. Adding or appending is nothing but adding a new element at the end of an array, that is at the next free space in an array. So we have an array of size 10, but we have only 6 elements. So we have next free space at index 6. So who says that 6 is a free space? Because the length is 6. So 6 means number of elements. So I have 1, 2, 3, 4, 5, 6 elements. Last index is 5, but it is keeping the count of number of elements. So index 6 is a free. So it's very simple. Just in an array of length, I can store an element, whichever element is passed here. So I can store x. So suppose I wanted to insert a new element, that is a 10. So 10 is inserted here. Then now I have total 7 elements. So this length should also become 7. So let us change that length to 7. So I must also update length after performing this operation. So length plus plus. So this will increase the length. So adding an element or appending an element means adding an element at the end of an array. So it's a simple syntax, just 2 statements. So what is the time taken by this operation? The time taken by this operation is, if I say each statement takes 1 unit of time for execution, so just 2 statements are there, so the time is constant. We say time is constant. Now here I will tell you what is the meaning of this constant. So let me go a little bit detailed here. See, the time that I got is 2, so function of time is 2. Now when the function is 2, then what is the degree of a function? So degree of a function is nothing but 2 into n power 0. So what is the degree? 0. So n power 0. So it is order of n power 0. So anything power 0 is written as 1. So that's why we write 1. So actually we mean n power 0. Instead of 1, we mean n power 0. So it's a constant. So the time taken, whenever you get any constant value, you got 2, so it's constant. If you get a 2000 also, it's constant. So whatever the figure may be, when it is a constant, so it's n power 0 and that value is 1. So we are not saying that This 2 is equal to 1, but we are saying that degree of a function is n power 0, that is 1. So this was the simplest operation. So we have finished how to display the elements and we have finished how to append. Now let us see insert. Next operation, insert. Insert operation takes index and the element. So this means inserting an element at a given index. So as an example, I have taken index as a 4 and the element that I want to insert is 15. So it means I want to insert a new element that is 15 at this place. But already some element is there. So I should provide a free space for that 15. So for providing free space, these elements should be shifted forward. Then a free space will open up here, then I can store 15. So for that, I should move 10, then I should move 9, then also I should move 6. Then a free space will appear here, then I can insert 15 there. So 10 should be moved here, 9 should be moved here. So how to do that same thing programmatically? See, I should start from last index 7, then standing there, I should copy the element from 6. So 10 will be copied here. Then move down to this location. Standing here, copy the element from this location. So 9 will be copied here. Then move I here. Standing here, copy the element from this index. So 6 is moved here. Then move I here. Then this is the place where we want to insert. So stop. When it became that equal to 4, then stop and insert the element there. So for that, I will write on the code. I has started from 7, that is length. So let I is starting from length. So I have to do this repeatedly. So let us say for. Then how long it should continue? While I is greater than the index that I want to insert at. So this is index and this is x. So index. Then I should be decrementing every time. Then as I said, when I was standing here, so it has copied the element from here. So at a of I, we should copy the element from a of I minus 1. That's it. So being at index I, copy the element from index minus 1. Then move I, decrement I, then copy the element from this index. Then decrement I and copy the element from this index. So being I kept on some index, I is on some index and copy the element from the previous index. So this process has to continue until I reaches this particular index. So when I has reached here, then simply we can insert this element 15 there. So at a of index, means the index at what we wanted, copy the value 15. So 15 will be copied here. Now once this 15 is copied here, the number of elements has increased by 1. So this 7 should become 8. So it means I should also increment length plus plus. So that's how we can insert a new element at a given index by shifting the other elements and providing a free space for the new element. Now one more thing we should take care here before performing the operation. This index should not be beyond the length of an array. See, total elements I have from 0 to 7, total 8 elements I have. And if I say that I want to insert at index 10 or 11, it should not go beyond length, or even it should not go beyond the size of an array. That condition we should check first. If it is valid, then we should perform this operation. So we'll be taking care of all those things when we write down the complete program. Now let us analyze this one. How much time it has taken for inserting an element? So what is the work done? The work done is shifting of elements. Then copying of element. Copying of element is a constant time. But shifting of elements, how many elements we are shifting? See, it is possible that right now, there are 8 elements and I want to insert at index 8. So no shifting required. Simply the element will be inserted here. So there may not be any shifting at all. That is 0 shifting. Or I want to insert an element at index 0. So index 0 means I should shift all the elements. So, and maximum shifting can be n. So we don't know how much shifting may be required. So either 0 shifting or n shifting, depends where you want to insert the element. If you are inserting at the end of an array, then no shifting is required. At the beginning of an array, then all the elements present in an array, that is, let us say n elements, all n elements we have to move. So the time taken by this procedure or this function is order of 1, that is minimum, and order of n, that is maximum. So minimum time is 1, maximum time is n. So whenever we mention the time, we try to talk about maximum time taken by any function or a procedure. So this procedure takes order of n time, but it is having minimum time as well as maximum time. So minimum time taken, we can call it as basic case time, and the cases we are inserting at the end of an array. And the maximum time can be called as worst case time, and the worst cases we are inserting at the beginning index of an array, that is index 0. So that's all about inserting an element at a given index. So we have finished this one. Now let us talk about deleting an element from a given index.